Hello class, good morning, afternoon, everybody watching this video. This is the video on the chemical kinetics lab, the formal lab report. Today I'm going to show you guys how to manipulate your data and what exactly I'm looking for. Now I know this video is a long time coming. I do apologize. Instead of converting all your Logger Pro data into Excel, because a lot of you guys had messed up data, I didn't want to do that. So what I did is I took the three best data sets. Data set 1, 2, and 3. I'll be uploading those in one of your class. You're using that data set. Sometimes even one of these data sets might be the best. I'm going to show you what's going on. Before I begin, let's talk about what I want in the lab formal. This is from your student guide that is in the Lab Cloud. There are 6 parts. First is a title page. This is APA format. So just go to the student resources, APA format guide, boom, title slide is done. Bada bing, bada boom. That is gone. Abstract. This is the last thing I want you guys to write. The abstract is going to be a summary of everything else. It's going to tell me the problem, the main idea. It's going to summarize a little bit your data. It's telling me what your data is. And then finally, did you prove anything? Data calculations. Come down here. Big thing right here. It says data. Oh, sorry. I introduced. Wow, it's missing there. Introduction overview should be between abstract and calculation. I don't know why it's not there. But this introduction overview is very, very important. This is where a bulk of your paper is going to be. This is 1 to 2 paragraphs, maybe 3 to 4 if you want to type a lot. Remember, this is chemical kinetics. So what you guys to do is do some background research in the lab manual or online, the textbook, whatever. If you want to make sure if you do something online, you have to cite it about why kinetics is important, right? Why is it useful? What are the 3 laws? First order, second order, zero order. What do they mean? And then next up, what are we using? What are we testing it for? Remember, this is where we took the crystal violet, put NaOH into it, and we put it into a UV vis scanner, and we saw what happens with concentration over time. What's going to happen? Why do we use three graphs and stuff like that? What are we solving for? That's what I want for the introduction side. Data calculations. The data calculation is going to be basically your graphs. You're going to put 3 graphs in there, your initial graph, the ln of the initial graph, and the inverse of the initial graph. Once you do that, you got to tell me what each one means. Well, and which one does it prove first order, second order, zero order? Which one it is? I already told you which one it is in class, but you got to tell me in the paper. Results. What does the graph mean? What does it make sense? Yes or no? Discussion a little bit above. Basically, what is the quality of your data? Do you believe yourself accurate? Do you think you have to read the lab? If you did the read of the lab, what would you do? Type of stuff's gonna happen, type of errors that could occur, systematic, stuff like that. That's what we do there. Okay, so let's go through data set 1. Okay, data set 1, A is going to be time. 300 seconds, like I told you guys to do. And here is the concentration over time. And here's the wavelength, key thing. So the first graph you make just by taking 2 data points all the way down, insert, graph, scatter. Add the chart elements and everything, but that looks really good. Now, you notice it slopes downwards, which it should, because the concentration is going down over time. Remember, we had the crystal violet NaOH. It became clear over time, so it should go down to nothing, which it does. Now remember, in lab class, we love linear graphs because we hate calculus, because calculus sucks. You can thank Isaac Newton for that. Fun time. So since we don't like this type of curve, we're going to manipulate the graph to do it. And we can't manipulate time because time is time. We can manipulate concentration. So what you can do is you can just take all of A to a whole new data sheet. You can paste that in. Oh, sorry about that. Take all of C. And we're not going to put it directly there. I'm going to put it over here off to the side. You'll see why. Cool. And then in E, hit enter, ln, 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 had it working before, had it working before. Nope, that's not it. Yes, one moment. I gotta answer something's going on. Answer something real quick. Sorry about that. My dogs were fighting over food. The big one beat the small one up. Another bees being a big beanie. And now back to hit. So you're gonna hit equal L. Don't put LN. I know I figured that out. You're gonna click LN right here, and then yeah, click on it. And then it's gonna add a number. You're gonna click on reset. Hit enter. Bing. You're gonna take what's this, and you're gonna drag it down a couple. And you can see it's gonna do the LN for all your data points. Super nice. That's why I like Excel for stuff. Okay, hit Control C, put it over here. You now can then get rid of these two data points because we don't need them. Okay, and then I'm going to take all my data points right here, and I'm going to do an insert graph. Hey, this one looks way more linear. I'm going to move it up here. It's fine. Doesn't really matter where. I just like it. See, it's way more linear. Taking the ln of your concentration is showing first order. Now, here is the thing I'm going to show you guys, because you guys will find this eventually. These don't shrink on me. Oh, it doesn't. Cool. So, you notice here, first order, without manipulating data, we get this. Basically, it goes all the way down and stops. Okay. First order. That's what a graph kind of looks like. The second order is really close too. Let's get the ln. Hey, my slope went down. I wonder what order your data is. I wonder what order your data is. Again, I will say it. I wonder which one your data is. But we have to prove it. And to prove it, we got to do this. We go back to this. Back to sheet 1, copy A to sheet 3. Get back to here, get your data. Now we're going to go to C. And then we're going to go over here. We're going to type in enter, and 1 over P1 should get a value. Move all the way down. See? Paste. Insert chart. Oh, it's increasing its inverse, but you see how it's kind of curved? We don't want curved graphs. Remember, physics bad. So, which one is linear? I wonder which one is linear. The linear one is the correct one. So in your introduction, what I also get to talk about too is what each of the orders mean. So what does zero order mean? Well, for a little quick recap for you guys, because I know it's been a hot second. If, say for example, I have concentration of 2 to the 0 power, concentration, well, something, and we have concentration, I don't know, 3 to the 1st power. Concentration of 0 is 1. I could put any number there. 9,999, it's still 0 order, it's to the 1st power. Basically, which means to the 0 order, it has no bearing on the chemical reaction. I can add the world's supply of plutonium nitrate to a reaction with plutonium nitrate. If it's 0 order, I just wasted the world supply. It doesn't do anything. It's not bearing. We had crystal violet, we added NaOH, and it got clear. And color change is indication of a chemical reaction. So something did occur. If you put 0 order, you are telling me that nothing occurred, which is wrong. If you do that, I will grade you wrong. First order, like just this one right here, concentration of 3. I know it's badly written. Again, I'm writing on the thing. It basically is whatever I do to the concentration, it happens. It's 1-to-1 order, right? So if I have, I don't know, 9, or say I have a reaction, remember that reaction order only cares about reactants. Let's say I had X and Y, and I double my Y. Well, if Y is first order, right, I double, my rate should double, right? This is rate. My rate will double if X is 0 order. Okay. If I'm in second order, you double what you double, technically. So if Y is second order and I put 2 in there, well, my rate is quadrupled. 3, it's quintupled, or whatever times 2, it's the ninth is, whatever. But second order basically is whatever you put in, you get double the amount out. That's what happens. Did our things get cleared doubly? I don't know. Did it, or should it get cleared twice as fast? I don't know. Did it? Look at the data. That's what I want in your introduction, and a little bit in your data calculate, and a little bit in your discussion too, is talk about what the orders mean. Now, I know this is due the 25th. I know I got to you pretty late. I'm going to grade these very, very nicely. As long as you put at its first order, give me all the 3 graphs, and give me a decent the background and a good enough discussion, you'll get good points. If you don't put first order, I'm already going to knock you down a lot of points because I have told you 5 times now that it's first order. Don't put 0 or second order. If you do, you will lose points. Do not tempt me. Okay, there you go, guys. That's what you're going to do. Okay, have at it. Stop share and stop recording.